In the following presentation, we're going to consider two extremes or equal opposites of each other. We have a galaxy made up of mostly dark matter, and then we have a galaxy made up of almost no dark matter. So before we jump into the details, I'd first like to give some background on the role that dark matter plays in galaxies. And then I want to consider the galaxy classification that these two odd galaxies fall into. And then after we have some ample background information, we'll dive into why these galaxies are so odd and what questions that they leave us with. So first, I want to show the rotation curves of our Milky Way galaxy and some other galaxies. You can see those in the graphs on the slide. And one thing you might notice is they all have the same shape. So the reason for that being the rotation curve of our Milky Way galaxy shows that the stars near the center and the ones further out have the same orbital velocities. And the graph showing the other galaxies is telling us the same thing too. Now, the only way that this can happen is if the mass is increasing with distance from the center of the galaxy. And this might seem odd since optically there aren't as many stars in the outer regions of the galaxy. We typically see most stars near the center. However, this graph is showing us that most of the mass is not in the center, but much further out. And this extra mass in the outer regions with little stars is what we call dark matter. And it acts like a structural glue that holds the galaxy together. So this massive dark matter surrounding the galaxy is called a dark matter halo. Dark matter typically accounts for around 90% of the mass in a galaxy. But how about some less conventional galaxies? So first, I want to talk about ultra diffuse galaxies. What are they? These are very faint galaxies, as you can see in the photo I have on the slide. They're normally found to have very little stars, very little star formation, and they tend to have lots of globular clusters. And those are spherical collections of gravitationally bound old stars. Um, Ultra diffuse galaxies, they also have a mass that indicates they are much larger than they optically appear. And the reason behind their unobservable mass is dark matter. And that dark matter makes up approximately 95% of the galaxy. And comparing this to the approximately 90% dark matter found in the average galaxy, we can see that diffuse galaxies have a higher percentage of dark matter and significantly smaller numbers of stars. So we'll see soon though that there have been ultra diffuse galaxies found that have low amounts of dark matter, but they're not very common. Okay, so how do these dark matter dense galaxies form? Currently, it's unknown, but there was a research study done in 2021 by Kirill A. Grishin, and his team looked at 11 ultra diffuse galaxies that had relatively younger stars to understand how they ended up as ultra diffuse galaxies. The team concluded that these galaxies formed around 12 billion years ago, but recently in the last billion years have had encounters with other galaxies, causing RAM pressure stripping that triggered a last starburst phase and then stripped the remaining gas from the galaxy. So this wow, this caused the galaxies to become the ultra diffuse galaxies we see today. And all 11 galaxies were found to have RAM pressure stripping tails and recent star formation, which led to these conclusions. And the team believes that half of the ultra diffuse galaxies formed in this way. So here we'll talk about Dragonfly 44. This is the first of the two odd galaxies I want to talk about. And you can see a photo of it on the slide. Dragonfly 44 is an ultra diffuse galaxy. One of the first things you might notice about it is that it appears to be a very dim light and you can almost see through it. The team that discovered Dragonfly 44 measured the galaxy's mass using both the orbital velocity law and by counting the number of globular clusters in the galaxy. And it was found to have approximately 94 globular clusters, which correlates to a pretty large dark matter halo. The team also measured the star's velocities for over 33 hours and they found them to be moving much faster than their visible mass could capacitate. So the team concluded from their data that Dragonfly 44 is similar in mass to the Milky Way, but has 100 times less stars. Only 100th of a % of the mass is in visible stars, and the other 99.99% is in dark matter. So we can see that dark matter plays a pretty important role in this galaxy, and that it has the right build to be an ultra diffuse galaxy, as we saw in the previous slide. But it does stick out because while most ultra diffuse galaxies have high amounts of dark matter, Dragonfly 44 is pretty much all dark matter. So the team was pretty puzzled on how a galaxy like this could form, but the lead researcher, Peter Van Dokkum, had a few ideas. So, how did Dragonfly 44 come about? Uh, it's possible that it happened in the way that Grisham's team suspected for those 11 ultra diffuse galaxies. But the main difference here is that Dragonfly 44 didn't have a recent burst of star formation or any young stars. Most of the stars are in the form of globular clusters, which are very old gravitationally bound stars. Van Dokkum, the lead researcher, he can't say conclusively what happened, but he does suggest that Dragonfly 44 had a mysterious event happen early in its history that caused its star-making gas to disappear, leaving just the dark matter and the stars behind. Over time, those stars got old and diminished. Other ideas have been proposed by other researchers disputing how much dark matter that they found. But Dokkum, he stands by his research team because this galaxy is simply too old and too bare in terms of stars to not have this massive of a dark matter halo. For Dragonfly 44 to hold together for about 10 to 13 billion years with so few stars, it would need the massive dark matter halo that they calculated. Otherwise, it would be torn apart. So could this mysterious event happening early in Dragonfly 44's life be due to ram pressure stripping? It's a possibility, but Van Dokkum also hypothesizes that it could be due to two small galaxies that were rotating in the same direction, and then they merged, causing an angular momentum that puffed out the star-forming gas in the galaxy. Okay, so the next galaxy that I wanted to talk about is NGC 1052 DF2. This is also an ultra diffuse galaxy, but it's special because it was the first galaxy ever discovered to have no dark matter at all. This brings in many questions because it goes against both the standard model for galaxies and ultra diffuse galaxies. We normally expect dark matter where we have normal matter, but this galaxy shows us that dark matter is truly something separate and isn't always coupled with normal matter. Peter Van Dokkum, the same researcher who found Dragonfly 44, he calculated the mass of this galaxy using the orbital velocity law and by looking at the velocities of the globular clusters in the galaxy. And he found that the movements of the globular clusters could be accounted for completely by the mass of the optical material in the galaxy, leaving no room for dark matter. So the globular clusters were found to be moving 3 times slower than those in galaxies with dark matter. And another odd thing about the galaxy is that the globular clusters are 2 times larger than most globular clusters. And the team isn't sure if this has something to do with the lack of dark matter. But they did use 5 different telescopes to confirm that this galaxy has little to no dark matter. And remember, most ultra diffuse galaxies have an overabundance of dark matter. So how do we go about explaining a galaxy like this? So Van Dokkum's team found that NGC 1052 DF2 has not had interactions with another galaxy. It also doesn't have the features of either a spiral or elliptical galaxy, and it doesn't have a central black hole either. The team was puzzled on explaining how this galaxy formed, since there's no current theory that predicts this dark matter-free galaxy. There were 2 ideas proposed by Van Dokkum, though, and they both have to do with the galaxy NGC 1052. I know the name is similar, but NGC 1052 is a dominant galaxy in the cluster that both of these galaxies are a part of. So the team suggests that when the massive elliptical galaxy NGC 1052 was forming, its size may be a reason why our galaxy with no dark matter is so deficient in dark matter. They also proposed that a massive gas cloud that was moving towards NGC 1052 when it was forming could have fragmented and formed our galaxy that we're considering. And the strong winds coming from NGC 1052's growing central black hole could have helped the process. The team was pretty clear, though, that neither of these ideas explain all of the odd things found out about NGC 1052 DF2, like the extra large and bright globular clusters moving at very low speeds. One thing we have learned, though, is that there's likely more than one way for a galaxy to form. But as for this galaxy, the researchers really just aren't sure, and they're looking for similar galaxies that may help us understand NGC 1052 DF2 a little better. So, in conclusion, even though we have some ideas to explain these two odd galaxies, neither galaxy has a conclusive explanation for its puzzling build. We learned in the beginning that galaxies typically have dark matter halos that work like glue holding them together. Dragonfly 44 does have that glue, but it seems to have lost its stars and gas. On the other hand, we have NGC 1052 DF2, and it doesn't have that glue. It just has the stars, which is even more puzzling. We then learned about ultra-diffuse galaxies and their mysterious formations and excessive dark matter. We saw that Dragonfly 44 fits the build for an ultra-diffuse galaxy much more nicely than NGC 1052 DF2 does. NGC 1052 DF2, it has all the defining qualities except for having a lack of dark matter. Now, Dragonfly 44 can likely be explained by a mysterious event that puffed out the star-forming gas, but NGC 1052 DF2 cannot be explained by a mysterious event puffing out the dark matter. As far as we know, there's nothing that can interact with or move dark matter. So this galaxy must have formed without it. So what questions are we left with? Conclusively understanding how ultra-diffuse galaxies form can help explain how Dragonfly 44 formed, and conclusively understanding how a galaxy forms without dark matter could explain how NGC 1052 DF2 formed. Additionally, if we're able to understand dark matter and what it truly is, it may be able to explain the part it plays and lack thereof in these two galaxies. Thank you.